Welcome back, guys. This video is fairly straightforward and simple. Again, not entirely solving anything or working things out too extensively here, but it does depend on your ability and familiarity to substitute values into any algebraic equation, whether it's linear, whether it's quadratic. Substitution and solving is key and important in this case. So we're going to set up a couple of tables just to sketch a few graphs. First one is y equals x squared, which is a very generic and the most basic of quadratic graphs. Okay, and we'll have a table here. We'll do that. And we'll have our x value is -3, -2, -1, 0, 1, 2, 3. And remember, your x values are your input or your independent variable, and y is your output because y is dependent on x. Okay, so y is dependent and your x is independent. All right, so what we have as a table, we're going to determine what the y value is, or what the coordinates for the y value is when we substitute each of these x values into our equation here. Okay, so if x is -3, squaring that makes it 9. Okay, if -2 is substituted into x, then we'll have 4. And then -1 squared is 1, 0 squared is 0, and then we've got 1, 4, and 9. So you could see that it starts up high, and then it's decreasing. As it decreases, hits rock bottom before it turns around and goes the other way around. And you could see that symmetry, I guess, involved in this pattern. So the whole idea of this particular part of the chapter is basically sketching those coordinates, okay, into the graph. And obviously my graph is very, very rough, but it's just for demonstration purposes that you understand where things are going. So first set of coordinates is -3 and 9. So -3 and 9, let's go 3, 6, 9, and so it's about there. And I apologize, maybe what I'll do is I'll actually draw the Cartesian plane properly. It's probably worth doing that. Okay, so -3 is over here, and 9, 3, 6, 9. We're looking at that as our first coordinates. Then when x is -2, which is over here, then we're looking at 4. And then when x is -1, we're looking at 1. Then it hits 0 and 0, and then it goes back the other direction symmetrically. And so what we can do here is we basically join the dots and we have our parabola going upright. Okay, so that's what y is equal to x squared looks like graphically. If we moved on to something else, let's say y is equal to -x squared plus 2, we can see already that the -x squared implies it's going to be an inverted parabola. And we have a +2, which means, well, we'll see. We'll soon find out. But basically from previous videos, it is our y-intercept, and it is also our vertical translation. So it's going to shift it up 2 units. Anyways, again, this video just looking at plotting in points. Nothing else. Substituting the values in for x and working out what y is. Okay, so if x is -3, then squaring that is going to be 9, but we want the negative of that. Okay, so we're going to have -9 as our first number. Just to correct that, because we haven't added the 2 after that, so -9 So negative 9 plus 2 is equal to negative 7. So let me just repeat that from the beginning. Negative 3 all squared is equal to 9. But we want the negative of that because it's negative x squared. So we want that to be negative 9. And then when we add 2, we get negative 7. All right, so next number. Negative 2 all squared is 4. But we want the negative of that. And then we're going to add 2, which makes it negative 2. Same thing, if we have negative 1 all squared, negative of that is just negative 1. I'm going to add 2, then we get a positive 1. And then if we have 0 squared, obviously that's just 0, but we're going to add 2 to that value. So we have 2. What we would expect is that then if we substitute 1, 2, and 3, we can see, and you can substitute it, we'll get the same values in reverse to provide that symmetry. Okay, so let's substitute those values into our graph. We've got minus 3 and 7, so 1, 2, 3, 4, 5, 6, 7. So that's our first coordinate. Minus 2 and minus 2 is going to be here. Minus 1 and 1. Minus 1 and 1 is over here. And then 0 and 2 is over here. And then we're going back down to these coordinates. And what we'll have here when we join those dots is we have that parabola looking like that. Okay, so first thing, we can see that it's inverted. It's a negative of x squared. Yes, it's upside down. And positive 2, we could see that it's not turning at the origin of the Cartesian plane, but it's shifted upwards 2 units. Okay, so it fits those descriptions. That seems quite good. All right, I'm going to graph one more. And again, this is just all practice of algebraic substitution, nothing else. In this case, I'm going to use the graph of y is equal to 2x squared minus 5x plus 1. Same table of values. There we go. Okay. We'll have minus 3, minus 2, minus 1, 0, 1, 2, 3 as our values. We're going to substitute x into our equation up on the top as per normal. So we'll do the same thing here. So we've got 2 times minus 3 all squared minus 5 times minus 3 plus 1. So minus 3 all squared is 9 times 2 is 18. Minus 5 times minus 3 is plus 15. And then we have plus 1. So 18 plus 15 is 33. 33 plus 1 is 34. So our first value is going to be 34. Okay. Second value is 2 times minus 2 all squared minus 5 times minus 2 plus 1. So we got 4 times 2 is 8 plus 10 plus 1. So we've got 19. Then the next value is going to be 2 times minus 1 all squared minus 5 times minus 1 plus 1. So we've got 2 plus 5 plus 1 is equal to 8. And then if we substitute x with 0, we'll end up having 2 times 0 squared minus 5 times 0 plus 1. Obviously, anything multiplied by 0 is just 0, so we're left with just 1. And then we'll do the other 3 values as well. Okay, so 2 times 1 squared is just 2. And then in this case now, let's, maybe I should just draw it. So 2 times 1 squared minus 5 times 1 plus 1. What we'll have is 2. But now we have minus 5, and then we have plus 1. Okay, so 2 minus 5 is minus 3. Minus 3 plus 1 is minus 2. Okay, so this is where it becomes a little bit trickier. But again, substitution, don't just assume that the right-hand value is going to be exactly the same as the left. And when we plot these things, you'll see how it all eventuates. So let's substitute positive 2. So 2 times 2 squared minus 5 times 2 plus 1. We have 2 squared is 4, 8. 8 minus 10 plus 1 is equal to negative 2, negative 1. Okay. And then lastly, we're going to substitute 3. So 2 times 3 squared minus 5 times 3 plus 1. We'll end up getting 9 times 2, 18, but 18 minus 15 now. We have 18 minus 15 is 3. 3 plus 1 is 4. So there's our table of values. Now let's substitute these values onto our Cartesian plane. And I'll just quickly draw a new Cartesian plane here, and we'll plot the coordinates. Okay, for room purposes, I'm going to just do a rough sketch here. So minus 3 and 34. So minus 3 and 34, let's just say it's up the top here. Minus 2 and 19, let's say it's something like that. Minus 1 and 8, let's say it's something like that. And 0 and 1 over there. Then when x is 1, it's minus 2. So putting it there, and then when x equals 2, it's minus 1. And then when x equals 3, then y equals 4. Okay, so let's put that over here. Okay, so what we can see here is our graph is going to look like this. Now, if we predicted how things were to continue, then we would think that it would go something like that. Okay, if we're to predict and project the rest of the graph. So again, at this point here, just making sure that you plot your coordinates, well, exercise and being able to make sure that you are substituting the values into the quadratic function correctly, and then just applying that onto the Cartesian plane. Then you connect the dots, and then you have your graph. Okay, hopefully that helps you. If you have any questions, let me know.